Everyone. So we're going to talk first about data visualization and logging. So my name is Jonah. I am a senior and currently the software lead for team 6328. So just a quick agenda. We're going to start with a brief introduction of logging in general in FRC, what that can look like. There are a few specific tools that we're then going to talk about. So WPILib, Advantge Scope, and Advantge Kit. And then I have a few case studies to talk through so we can look at what some of those tools look like in action. Okay. So first of all, before we get too far into this, I want to break down when we talk about data logging in FRC, that can mean a whole host of different things. And generally, I like to think about it in these three categories. So the first one, level one, the simplest category is pure driver station logging. Building in complexity is onboard logging. And then the level 3 logging is log replay. So all of these different approaches have some trade-offs and some benefits. So I want to talk about each one in a little bit more detail. Driver station logging, this is the simplest form of logging in FRC. So it's built right into the driver station, which means that it works automatically with no setup. There's nothing that you have to do in your code to support this. And it records simple data. So things like battery voltage, current draw, network diagnostics, text from the console. So all really simple fields that the driver station already has access to. And so this is really good for diagnosing simple issues after matches, but it's not very customizable. So for example, you can diagnose simple electrical issues using a driver station log. Like if a motor is disconnected, you're not going to have current draw on the channel you expect. The console logging aspect of this can also sometimes be useful for diagnosing code problems. For example, if you get a stack trace, but it's very limited in functionality. So we can go one level up, get some more benefits with onboard logging. So this is when we're recording data directly from our code to a USB drive or the onboard Rio storage. And also in this category, we can support network streaming so that you can do live data visualization over the network, see what's happening without using a log file. There are a lot of options for doing this, especially historically, but currently WPILib actually provides a very nice solution for this, which we'll talk about a little bit later. Now, of course, the downside is that this does take more effort to set up because it's not automatic, but it is far more flexible than driver station logging. You can log sensor data, internal code state, odometry data, pretty much anything you want. The other downside to this approach, though, is there's also still a risk of not logging the necessary data that you need to debug a problem. So often it's really important to go in logging lots and lots of fields, because otherwise there's a risk that the one field you need to solve your problem you forgot to log, which is unfortunate. So that brings us nicely to level 3 logging, which is log replay. And the whole point of this is to address that final flaw of onboard logging, of potentially not logging the right field. So level 3 logging, we also can call log replay, or we can call log replay or log everything. So you'll hear both terms. And we'll go into some more details later about what exactly that means. But essentially, the goal of level 3 logging is that we can replay the entire internal state of the code based on a log file. So we can inspect literally down to each line what the code was doing after a match. So it's very powerful. And there's never a risk of not logging enough fields because you can always go back to the internal state of the code. This is, of course, far more complex to implement than level 2 logging, but for each team, that trade-off may be worth it. And level 3 logging, there are several different tools to do this, especially because it's a common approach in industry. So one tool that you'll hear about often is ROS, the robot operating system, which is capable of this style of logging. We're particularly partial to Advantge Kit, which is 6328's framework that we've developed for doing level 2 logging, and it's built on WPILib. Okay, So now that we've discussed sort of the big picture of what logging can look like in FRC, I want to dive into a few more specifics. So first of all, if you're just using driver station logging right now, I can't recommend highly enough that you at least explore level 2 logging. And remember, that can include both live and historical logging, so streaming over the network and saving to a log file. So for WPILib, live logging is using network tables, and historical logging is using a custom data format, WPILib data logs, which we'll often shorten to WPI logs. And those tools are built right into WPILib, so it's easy to get started with any robot code project. WPILib's recommended approach to doing this is that you log all of the fields you care about directly to network tables, which will then be captured and saved automatically to the WPI log. So it's really convenient. And I have a few lines here that demonstrate very simple usage of this. So the first line there, we start a data log session. So that'll begin capturing network tables data. The next line links the driver station class. So that'll log the robot status, whether it's enabled, and joystick data. And then the last line, just an example of publishing a field to network tables. So that will be both streamed live and saved to the historical log, to the WPI log file. And if you want details on any more of this, you can go to docs.wpilib.org, search telemetry or data log. There is way more depth to this than what is covered on this slide. So definitely look into that. Okay. And I also want to briefly touch on, there are several tools that are included in WPILib for doing log analysis. For live logging, streaming over the network, the most common dashboards are Shuffleboard, which you may be familiar with as an on-field dashboard, and Glass is another tool they provide, which is specifically designed for programmers. So that's more for debugging in the shop. I also want to shout out FRC Web Components. So this is a different tool that is currently under development, but it's becoming a really appealing option in this space. For historical analysis, so reading log files, WPILib's built-in tools are definitely more sparse. So the data log tool, which is included already in WPILib, it can download WPI logs from the Rio and convert them to CSV, but not much else. Sapphire is a more complete tool, but it's still in early development. So that leads us nicely, though, into Advantge Scope. So this is the next tool I'd like to introduce. So Advantge Scope was a tool that was developed by 6328 for log analysis. We started developing it in the 2021 off-season. Then we've made some big improvements over this past 2022 off-season. So adding support for more
Uma grande melhoria no software.
Few of the features are shown here. We'll get a better look at that later. And the first thing that I want to make clear about this, so Advantge Scope is compatible with all levels of logging, all levels 1, 2, and 3 that we've been talking about. So it can open driver station logs. In general, we prefer the Advantge Scope interface compared to the built-in driver station log reader. Advantge Scope can also open WPI log files produced by the code you just saw. It can connect to network tables for live analysis, and it can open logs that are produced by Advantge Kit for level 3 logging. Advantge Scope has options for both historical and live analysis, and all of the visualizations work across both of them, and you can seamlessly switch between. And currently, Advantge Scope is really the only option that'll allow you to seamlessly switch between those. It has a whole bunch of different visualization tools, line graphs, 2D and 3D field displays, video playback, joystick visualization, etc. As I said before, we will return to Advantge Scope to see some of those in action. Okay. I want to switch gears for just a moment and talk about Advantge Kit. So Advantge Kit is the last tool here, and it is 6328's library that we've developed for level 3 logging.
É a biblioteca do 6328 que a gente fez para
Now, to understand level 3 logging in general, we need to simplify our view of the robot code. So here I have a very simple diagram. Fundamentally, all the robot code is doing is it's reading a set of inputs in order to produce a set of outputs. So inputs are things like encoder values, joystick buttons and sticks, the enabled or disabled state, and any other sensors on the robot. So it's anything that the robot code is using to make decisions. The code then has some internal logic. So things like timed robot, command subsystems, all the code you're familiar with. And it produces outputs, things like motor voltages, pneumatic commands, the odometry pose, a flywheel set point. And notice that some of those, like the odometry pose, we still consider an output because it was calculated by the robot code, even if it's not directly sent to another device like a motor controller. Now, I'm just going to add some arrows here. This is what level 2 logging generally looks like. So we're sampling a few key fields from both the inputs and the outputs. So things like maybe the joystick values for the driver controller, plus the odometry pose and the applied flywheel voltage, say. Now, of course, the downside is we can't look at any fields that we didn't log. So to fix that, here's what level 3 logging tends to look like. Now let's break down each part of this. So first, instead of logging just a few fields, we're logging every input field. That's really important. Any data that the code uses must be logged, regardless of the source of that data. But why? Well, if we run the same robot code in a simulator and we replay the inputs based on the log file, the code will do exactly the same thing as it did on the real robot. Now, that's kind of a wild idea, so take a moment to wrap your head around that. If the same code receives the same inputs in the same order, it will always do the same thing. That means that we can measure all of our outputs from the simulated code and be guaranteed that they are the same as on the real robot. This also means that we can even adjust the robot code to generate more outputs than the first time, like data we forgot to include in the log file. Okay. Excuse me. So this is good in theory, but let's also talk about how it changes the robot code. Advantge Kit needs to be able to log and replay all of the code's input data. So there's a lot of this data that's managed automatically by Advantge Kit, like the robot state, joystick data, Brio status, and power distribution data. And I also want to note that timestamps are listed there. Advantge Kit guarantees that all timestamps that are read during a single cycle are identical so that they can be replayed. This means that Advantge Kit produces what we call timestamp synchronized logs, which means all fields are updated once per loop cycle, and each loop cycle has a single timestamp. So in order to guarantee that the data going to the robot code is the same as the data going to the log, Advantge Kit actually shims or replaces several WPILib classes to make this work. Now, the other side of this are any inputs that are part of subsystems, so things like encoders, gyros, limit switches, things like that. And this is the biggest difference that Advantge Kit introduces to the robot code. We have to ensure that the subsystem logic is separated from the hardware interface, which we call the I/O layer. So in this example, we have a flywheel subsystem, which can run PID controllers, check when the flywheel reaches the set point, or calculate the correct speed for the current distance. The I/O interface, which is literally a Java interface, defines the input data, like the flywheel velocity and position, and methods for setting outputs, like commanding the voltage. We then write an implementation to talk to the hardware, like a SparkMax controller. And so when running on the robot, Advantge Kit is recording all of the input data from the I/O layer. And then the fun bit is that when we're running a log replay in a simulator, All we need to do is disable the IO implementation, and Advantge kit produces the data instead. So the subsystem and the rest of the code can't tell the difference between the real hardware and the replayed log. I'll also note the IO layers have another nice benefit, which is that we can write multiple of them. So for example, we could have a flywheel IO sim, replace our real implementation with a physics simulator in order to test the code before the real robot is ready. We could also write, say, a Talon effects implementation if we had a practice robot with different hardware. Okay, so now for the remainder of the presentation, I want to walk through a few case studies which utilize both Advantge Kit and Advantge Scope. And these are all based on 6328's 2022 robot code, which used Advantge Kit. And so first, here we have a simple example of using log replay to generate extra outputs from a log file. So here, we'll start by looking at one of our log files from the 2022 championship. So here we have Advantge Scope open. What we're going to do is open up the log file that we downloaded from the Rio. That's going to load. And then here under driver station, we can look at the robot's enabled status and the flywheel goal RPM, which is essentially the set point RPM. And so there you can see when the match was being played and what our flywheel set point was, and just ignore the bits where it drops down to 0. That's expected. Okay, so the flywheel goal was a field that we explicitly chose to, was an output that we explicitly chose to log. And a little bit of background here, the flywheel speed was determined automatically based on the distance to the goal. So that was using a linear interpolation. And let's say we wanted to check that that relationship between distance and speed was accurate. Unfortunately, it looks like we forgot to log the distance to the target. Now, the measured distance is based on the robot's odometry, which in turn used vision data, wheel encoders, gyro angle, etc. as inputs. And because all of those inputs are logged, we can extract the measured distance to the target using the log. Except there's a problem. Let's return to this diagram for a moment. We said that the simulated robot code will behave exactly the same as the original robot code as long as it receives the same inputs, but there was another condition. The 2 copies of the robot code must be identical for that to work. The log we were just looking at was from back in April, and our robot code has changed since then. But luckily, our robot code was also checked into version control with Git and GitHub. Every commit that we make can be uniquely identified by its hash, which allows us to find a specific version of the code. Now, commits don't include any uncommitted changes that might have been deployed, of course. So we have a separate system for competitions where it's particularly critical to be able to replay every match, even if we're making rapid changes to the code. So we created a VS Code extension, which automatically generates a commit whenever we deploy. So here's an example commit log from the championship. All of these commits go on a branch in our repository, which we later squash and merge back to main, so we're not cluttering things. But the result of this is that every version of code that has run on our robot during a competition is available to us forever in order to do log replay. Okay, so let's return to our log file. Advantge Kit, one of the nice features is that we can record metadata into the log. So here we're going to open up a metadata tab. And then here, what we've just highlighted, we can see it stored the commit hash. And also notice where it says all changes committed here. So that means that there were no changes, that all of the changes in the robot code were included in that commit. So we can safely go back to the commit specified by the hash and be guaranteed of getting an accurate replay. So let's do that. Here we have our 2022 robot code open in VS Code. So what I'm going to do first is add a line that records the distance to the target in meters in our vision subsystem. Running git checkout, this will return to the old commit. And then we just tell it to simulate the robot code. So that'll take a moment to launch. Advantge Kit will automatically grab the latest log file from Advantge Scope for convenience, and now it begins replaying. Now it's running these cycles as fast as my laptop can handle them, rather than every 20 milliseconds. The timestamp, as we talked about, is being injected by Advantge Kit anyway, so it doesn't matter how quickly it plays it back. In fact, this is running about 50 times faster than real time, so we just replayed an entire match. And Advantge Kit now generated a new log file, which includes all of the original inputs, plus the new replayed outputs. Let's take a look. So back in Advantge scope, we're going to open up our replayed log file. So it generated, just a moment. Here we go. It generated a sim log file. Once that loads, on the side, we have a new replay outputs table. And under there is our target distance in meters. And remember, what we're looking at here in red, this matches the data that would have been on the real robot. But the replay is just based on the raw input stored in the log. And we can confirm based on this by a quick eyeball that the flywheel speed is going up when our distance increases. So everything appears to be working properly. Hooray. Okay. So for the next example, odometry filtering, this is we've seen that we can extract data from a log replay, but we can also use it if we want to test out some tricky bug fixes. So here, this is one of my favorite Advantge scope views. So this is our 3D field. And so we're just going to drag out a little bit of odometry data so we can take a look at this. And so once we begin playback, we can pan around, we can rotate this field and look at it however is best. And what we're seeing here with the green lines is our robot using vision data from the limelight to reset its odometry, its calculated position on the field. So the green line is when that reset is happening. The green robot is where it's resetting to. And we can also, in a moment, we'll take a look at we can actually switch to the limelight's point of view like this and see when the target should theoretically be in view. So that's really useful for comparison. Now, of course, doing odometry this way, there's a fairly complex pipeline involved, and filtering out invalid targets is critical to making that work. So what you're seeing here in this match is an example of the pipeline working pretty well. This is a good example, but it didn't always go so well. So here, this is a different log from an off-season event where the limelight picked up some spurious targets. So take a look at what happens here. We're in the blue hangar, and then as we come out of it, this happens. I'm just going to replay that. So we pick up some invalid targets, and the robot appears to jump across the field in a way that is totally unrealistic. So that's unfortunate. How can we rectify that issue? Well, let's use a different Advantge scope view to dive a little deeper. What we're looking at right now is raw data that is coming from the limelight. So on the right, these two windows are an example from a different log of what this should look like. So each plus on the top shows a corner of a detected target in the limelight's field of view, which are the pieces of reflective tape around the upper hub. So we can also compare to the limelight's perspective. On the right, they line up perfectly around the curve of the top of the hub. Now, the image to the left is from the problematic log that we just saw. So clearly those are not valid targets, but the code didn't filter them out correctly. And so they messed up the odometry pipeline. They caused us to suddenly fly across the field. So that's bad. How can we fix that? Well, let's open up Advantge Scope's table view and look at this more closely. So the highlighted line there is the set of X coordinates for the points that we were just viewing. So it turns out, if you count those up, there are 13 corners listed. Of course, the corner count should always be a multiple of 4 if we're looking at rectangular pieces of tape. Each one should have 4 corners. So let's try and fix this. Like before, we'll use the commit hash to return to this version of the code, but instead of logging extra data, we'll modify the code. So we'll add the lines shown at the bottom of the screen to the vision subsystem. All that this is doing is discarding the frame if the number of corners is not divisible by 4. So hopefully we're rejecting this invalid frame. Now we'll run the code in replay, just like before, except this time, remember, we're expecting the code's outputs to be different with the new filtering logic. So let's take a look at it. Here's the same clip as before, with the green robot representing the replayed odometry pose. So we can compare. So we don't teleport across the field. And in a moment, we'll get a actually good lock on the target. And there we go. So the two poses converge. I'm just going to replay that. So we can test our new filtering logic, and we see that it's working well. But the cool bit is that we can now run this code in future matches with confidence, because we know exactly what the code would have done if this new version was running on the field. So this is incredibly powerful between matches when you might not have access to a practice field or be able to recreate match conditions on a practice field at all. We can spend a lot of time iterating on these solutions and figuring out what would have worked best in matches that we already played. So it's a really powerful idea. Okay. Now, for a final example, I want to give one quick case of log data in action, and this one is actually possible with only level 2 logging. So let's take a look. So here I've combined a couple of useful Advantge scope views. So on the left is a match video, and Advantge scope has built-in tools so you can load a match video and synchronize it with a log file so that the timestamps are all matched up. And on the right, we have a visualization of the driver joysticks. So we have 2 Xbox controllers. The blue one on the left is for our driver, and the white one on the right is for our operator. Plus, at the bottom, you can load in custom images to Advantge scope. So this is our override console. And you can see at the top, we have a whole bunch of switches that we can interact with, which will override various things in the code. And as the match plays, we can see what the drivers are doing moment to moment. So for reference, our robot is the one up here with the purple lights on. Now, where we found this a view like this especially useful is for distinguishing between code problems and new drivers pushing the wrong button. Often it's really easy to get caught up in that sort of thing with wanting to distinguish between errors in the code and human error. So we've had some personal experience with this at off-season events. But there's another use case for this, which is reviewing driver actions after the match in order for the driver to improve. So here I've focused on a particularly sad moment near the end of the match. I'm going to replay this in 25% speed. So we're running back to the hangar, and then, oh dear. So the robot falls over and we stayed down for the rest of the match. And I'm going to replay this and make sure to pay attention to what the joystick is doing. So we're going backwards. And then as soon as we hit the cable bump, the driver releases the joystick. So of course, the top of the robot keeps moving when we land with the wheels, and the wheels are not turning. So we immediately tip over. Now, after a difficult moment like this in a match, sometimes it's difficult to know exactly what happened, what might have caused the failure. But using log data like this means the driver can go back and review their actions in detail, moment by moment, frame by frame, and understand exactly how they can improve. So certainly our driver never made this mistake again. But I think this really goes to show that logging doesn't just have to be valuable for the programmers. It can really be valuable for the drive team as well in order to go back and review matches in detail. Okay. Well, thank you everyone for listening. I have a few links up here if anyone wants to screenshot that to the various tools that we've talked about. But I think we're going to do questions now. Is that right?
Yes, it is. Thank you, Jonah. Of course, this kind of conferences, specifically the ones of programming, a lot of questions come up, but usually it is when we upload them to YouTube a couple days after, and then teams reach out to your team specifically for the doubts they had when they rewatch the video. But anyway, we
Yeah.
are open for any questions that may show up now in the Q&A section, if you're okay with that.
Yep.
So in the meantime, I would like to know, you made it to Roebling division last season in champs.
Yep.
So, and you won a Roebling division. So I'm pretty sure a lot of rookie teams may have came over to your pit at champs and reach out to you looking for advice. What would be your best advice for the derived teams and the programming teams and these rookie teams this season that are trying to give their best in the regional events?
Good question. So obviously that it's going to be different for every team. The main piece of advice that I can give is sort of generic, but working within your abilities. And I'm not a strategy person at all, but our team has been really thoughtful about particularly balancing mechanical design and software design and playing to our strengths whenever we can. So we've tended to lean more on on making robots that are simple and robust. We had very few failures of our robot in the mechanical failures in the 2022 season, but then we go really hard on software, as is perhaps clear. But that balance is going to be different for every team. So make sure to think about that carefully before kickoff.
Okay, cool. We got a couple questions.
Okay.
And for the first one from David, and it says, while it is listed on GitHub, would you still be okay with another team using Advantge Kit?
Of course, both Advantge Scope and Advantge Kit are all open source. We are here to support as best we can any teams that want to use one or both of those. So we are open alliance. Everything we do is public. So you can also look at our build thread. We'll be talking about our experience using them. So absolutely, yes, you can use Advantge Kit. Okay.
Next question from an anonymous attendee. Roughly how much time or how many hours do you dedicate to driver practices before regional events?
I don't know about number of hours. I don't have that number, but we had a drivable robot by about week four or five, preparing for our week 1 district event. So there was a lot of time actually that we would, like, for example, go in on a Saturday and be doing driver practice for many hours. And one of the things that we also learned is that software tuning and driver practice don't have to be mutually exclusive. That really helped us, particularly with live data visualization, live tuning. Like, while the drivers are practicing, the software team tended to be huddled in the corner looking at live data from the robot and retuning the mechanisms to get some better performance. But there were certainly a few days of at least 3 or 4 hours of driver practice, probably more.
Okay, 3 to 4 hours a day. Next question. There we go. How much time you dedicate to the automatization of mechanisms and to the robot itself? I guess it'll be time per day, I guess.
Yeah, well, so our meeting schedule is we have maybe, I think, somewhere in the range of 15 to 20 hours a week. In terms of like automating mechanisms specifically. So like as we're designing all of the mechanisms in CAD, like, we're thinking about the controls side of it as we're doing that. So there's a lot of consultation between CAD and mechanical and software on that. And so for the most part, all of the code writing of automating mechanisms we do before the robot is finished using simulation or whatever tools we have. I don't know about exactly how much time we dedicate to that. And then once we get the robot, of course, that's all pretty much all tuning. So like the basic logic is all there and we're just tuning constants and things. But hopefully that answers the question.
Next, what is your favorite Advantge scope feature and why?
Let's see. Well, so I already said the 3D field view is definitely my favorite view. I've spent perhaps an embarrassing amount of time just like looking at old log files in that view, because we didn't have that in the 2022 season. That was a development in this off season. And it's very exciting, particularly for, as we're starting to look at April tag tracking. A lot of that, we're moving from doing just pure 2D flat odometry to having more 3D poses and doing 3D transformations and things like that. So it's already been tremendously helpful for being able to visualize those things in 3D. And I'll also note there's some cool work going on, which I am not directly involved with, in using the, like I showed the limelight view, and using some of those fixed camera views in order to test out a full April tag pipeline in simulation. So being able to feed that camera frame back into a vision pipeline and then do calculations based on that. That's still in very early development, so certainly not certainly nothing immediately to look at there, but there's some interesting ideas on the horizon.
Alrighty, and maybe our last two questions. Do you have any specific way or in a specific trick or maybe tips to train new students and new drivers into the team?
Yeah. Well, so I'll comment on training new students specifically. So we're basically running all year round. So we have training programs throughout the off season. And one of the things that we really learned to do is to emphasize project-based learning in the off season. So two parts to that. One is all of our training programs. We, for example, our software training over the last off season, we had lots of groups of like 3 to 4 students working on real projects that were going to benefit the team. So things like an FLL scoring system for a qualifier, or writing our swerve drive code. The other thing that we do is we have every student conference with mentors at the start of training and the start of build season. So they're setting personal goals and they have specific things they want to get out of training. Yeah.
Okay, and our last question from David again. When did you learn how to make a program like Advantge and how long did it take to develop?
Well, so Advantge started development in like fall 2021. It was we started using it in the 2022 build season, so total development was a few months, and we've been iterating on it ever since. Same with Advantge Scope. As for when how I learned to make a program like that, mostly it's just practice from all of the other code that I was doing in FRC. So Advantge is written in Java, which will be familiar to most FRC developers, little bit of C++ in there. And Advantge Scope is all web technologies, so HTML, CSS, JavaScript, which I was already familiar with from doing scouting system stuff. So really, it's just having done projects with all of those same technologies and applying them in a new way. That's pretty much all it is.
Okay, well, there's your contact info. I guess, do you have any kind of email, Jonah, or your team has any way to contact you if teams want to reach out?
Yes, certainly. I don't know what the best way is to get that out, but we have a contact email. You can find us, our GitHub page linked there. And we're all active on Chief and Discord and all the normal places.
Yeah, you can write it down in the webinar chat and send it away, and everyone will be able to see it.
Yeah, perfect. Oh, I don't think I can send that generally, but for at least hosts.
Yeah,
there.
we can see it. Yeah.
Yeah, perfect.
Well,
okay.
we'll make sure to lend to any team that may ask for it.
Okay.
Jonah, thank you very much for being here. It's been a pleasure to have you with us. What an exciting topic you brought. And well, thank you for being in warm up.
Okay. Thank you very much for having me.
It's been a pleasure. Thank you very much.